Welcome to this YouTube session where I'll be walking you through a preview of ASBOG practice exam questions I've made to study. If you're preparing for the ASBOG, you probably want as much practice as possible before exam day. In this video, I'll be presenting a PowerPoint with a sample of the questions I've created, which are part of a 300 question exam series available right now on Udemy. These questions span across all of ASBOG's 8 domains. Now, you might be wondering, why is taking practice tests so important? Well, research consistently shows that learning by taking practice tests, also known as retrieval practice, is one of the most effective study strategies. This approach significantly improves memory retention and learning outcomes compared to simply rereading material and watching lectures. This is due to a well-documented phenomenon called the testing effect, where actively recalling information strengthens long-term memory and enhances understanding. It's also more fun. That's why this session is designed to not just test your knowledge, but actively improve it. By working through these practice questions, you'll reinforce key concepts and develop the problem-solving skills needed to succeed on the ASBOG exam. I know most of you already have this knowledge in your head from undergrad. You just need something to trigger it back into your working memory. Exams are a much better tool for this than rereading material from a textbook. So feel free to pause the video along the way, take notes, and test yourself. And if you find this helpful, be sure to check out the full Udemy course linked below for even more high-quality exam questions. Now let's dive into the first question. Okay, let's start with everyone's favorite, a strike and dip problem. If you're having flashbacks to structure class, don't worry. I'm going to break this down into logical steps that will make it easy to understand. So here's the question. A large shale unit, represented by this dark hatched area, is in your mapping area. Given that the distance from the 200-foot to the 100-foot strike line is 214.5 feet, what is the strike and dip of this unit? I'll break this down in a simple yet effective way to determine strike and dip without drawing on the map or performing any calculations. Just by using the process of elimination, we can quickly identify the right answer by analyzing contour elevations instead. So our focus is on the strike and dip, and to solve this problem we only need to use one contact and two different contour elevations. Let's walk through an example of using the southern contact of the shale. So this is the northern contact and this is our southern contact. We start by identifying where the shale unit intersects at two different contour elevations. So we see it intersects right here at 200 and here at 200. And it intersects here at 100 and here at 100. And all of these intersection points are on the southern contact. So if I connect the 200 and I connect the 100, we now have two strike lines. I'm drawing on the map for clarity so that you can understand, but you should be able to just look at this and imagine that when you're doing it on exam day. So since this 200-foot contour is north of this 100-foot contour, it's higher elevation than this one, we know that the unit is dipping to the south. If we look through our answers over here, we have one option here that's going to the northwest and this option here that's going to the northeast. Well, we immediately know that those can't be right. This is option C is the only one that's dipping to the south. And our first option here, this is a fold and not enough information is provided. It's just not right because this is a planar feature and it's just an intersecting variable topography. So answer C is the correct decision. This is what you would see if you were taking my test on Udemy. It would say correct answer, and then it would provide an overall explanation. So this is the overall explanation that would accompany it. It shows you what I'd drawn on the previous slide, the two different strike lines. The important thing to remember here is that the ASBOG administers the exams on computers now. So the days of drawing on maps are over. You can sketch it on a piece of scratch paper, but it's better to just reason it out and picture it on the screen. I have a very long description and an explanation so that you can understand while you take my tests. So in a lot of my explanations, I try to anticipate the kinds of things people get wrong. So this is a common mistake people make. We'll consider what would happen if we chose a strike line from the southern contact and from the northern contact. If we did the 200 on the southern and the 100 on the northern contact, we would think that this is dipping to the north, and that would lead us towards the wrong options in our multiple choice. They also will give you numbers in the questions to make you do calculations that might waste your time when you could just use process of elimination. So 214.5 feet between our strike lines. If you did want to calculate the dip from that, it would just be, here's our dip angle, the 100-foot strike line, the 200-foot strike line, opposite 100 feet, difference between 100 and 200, our horizontal 214.5 feet, opposite over adjacent, tan dip equals 100 over 214.5 feet, and that gives us a dip of 25 degrees. So remember, don't overcomplicate things. Don't waste your time. Try to just reason things out initially. Make sure you're always picking your strike lines for strike and dip on the same contact. The only time that you really use both contacts is if you're trying to calculate a true thickness, which I'll be doing in a future video. For this question, we'll analyze the cross-section over here and determine which topo best represents it. This is a 4-part question on my exam, but we're only going to examine one of them. And our goal is to find the correct answer with using the least amount of work possible. The question is, which of the following topos is represented by the cross-section to the right? The cross-section shows a landscape with a flat area up here at the top, a little steep section, and then another flat area. The pattern suggests a specific type of terrain where elevation changes in a really structured way, and we just need to find that structure reflected in the topos to the left. So option A has that flat section. It's followed by a drop. You see the topo lines are compressed here. There's a flat section here, and then another drop off, and then another flat section. That really doesn't match what we're seeing over here. We're only really looking for one steep section. So option B here looks like a depression in the ground that rises and falls if we went straight across. That doesn't really match either. Option C, we see compressed topo lines here. There's a strike and there's a bedding strike and dip right here as well. There's one flat section here and then another one here. That still doesn't really match up. So let's look at option D. Looks like it gently falls initially. There's one steep section where all the topo lines get really closely bunched together. And then we have a section over here, maybe the last quarter to a third of the topo is pretty gently sloping down, or flat even. That seems to match the best. So this is what you would see on the test. D is correct. We're given a domain, general field geology. All my questions are broken down by domain, so you can see if you're strong or weak in a specific domain. There's a summary at the end of the exam that will break it down by domain, what you got right and what you got wrong, so you can target your studying. And then there's an explanation for each of these other choices about why it's wrong. So again, a lot of these questions are not necessarily difficult if you slow down and just use the geological reasoning in your toolbox. Okay, in this problem, we're going to analyze sedimentary data from offshore drill holes to determine the correct sedimentary environment. So take a moment and try to recall that SEDS course that you took years ago. The problem is specifically this. You've received back drilling results for a preliminary study of the suitability of the seabed for offshore wind turbine foundations. The logs for the 3 drill holes and their locations off the coast are shown in the graphic below. Before you begin any interpolation, your boss wants you to come up with a genetic model. What kind of marine sedimentary environment is this? So here's our map with our boreholes. Here are our 3 boreholes, and our answers all involve transgression or regression, onlapping or offlapping. So that's what we should be focusing on when we are interpreting this. Borehole 1, which is furthest off the coast, contains limestone, typically forming in a deeper marine setting. Borehole 2 has that limestone overlying shale. And borehole 3, which is closest to the shore, contains sandstone and shale overlying that sandstone. So all of these boreholes suggest we have deeper marine sediments overlying shallower marine sediments over time. Immediately we should think marine transgression. Now, if we are certain that's transgression, we can knock out option 3 and option 4 immediately, which narrows it down considerably. We're left with onlapping marine transgression and offlapping marine transgression. Now all we have to do is ask ourselves, does onlapping make more sense here, or does offlapping make more sense? So the correct answer is onlapping marine transgression, option 1. Why is that? Well, offlapping never goes with transgression. Offlapping you should immediately associate with regression. Just semantics. Don't worry about it, or don't think about it too hard. Offlapping just refers to a seaward shift of depositional environments. Onlapping refers to the landward shift of sedimentary environments. Now let's just take a second and think about what these boreholes would look like in the opposite scenario if we were seeing regression. Well, if it was regression, we would see sandstone overlying shale, shale overlying the limestone. It would just be the exact opposite of what we're seeing here. So ASBOG likes to include a lot of regression, transgression kind of questions on the exam. Sometimes they'll give you a map that doesn't tell you what all the layers are, and they'll just give you a range of layers and say, oh, this is a regressive environment or a transgressive environment, and you need to fill it in from just one layer. So having this in your toolkit is extremely important. All right. Let's dive into another important concept and a question that you should expect to see on the exam, at least one of these guys, the grade and slope angle. And this is just a simple calculation question, low-hanging fruit for any test taker. So here's the question. A 3:2 horizontal to vertical slope has what grade? What is the slope angle? Our answer choices are 50%, 26.6 degrees, 60%, 31.8 degrees, 67%, 33.7 degrees, and lastly 75%, 37 degrees. So take a moment to think about how to solve this. Remember, slope grade is calculated as grade is rise over run times 100, really basic math. So for a slope that is 3:2, the rise is 2 units and the run is 3 units. To find the slope angle, we'll need to also just use the inverse tangent function of rise over run. So pause the video if you want to try calculating it real fast, and when you're ready, we'll walk through the solution. So this is just some basic math. 2 divided by 3 gives you 0.67 multiplied by 100, 67%. The only option that has that is option 3, so we'd automatically know that's the right answer without having to calculate the arctan. But if you did arctan of 2/3, you get 33.7 degrees. So that's our answer right there. So they like to throw at least one of these at you. So keep this formula in your head so you can be there on exam day, get that low-hanging fruit, and calculate with confidence. So here's our last question. It's in the petrology geochemistry domain, specifically radiometric dating and isotope pairs. So the question is, what isotope pairs are useful for age dating granites? So select all that apply. Pause the video if you want. Take a second to think it over. Okay, here we go. So if you chose uranium lead and rubidium strontium, you're on the right track. These are the isotope pairs that are widely used for dating igneous rocks like granite. So why not carbon-14? Well, there's not a lot of carbon in granite in general, but it also has a very short half-life of 5,730 years. It's pretty short for granite, which when we're thinking usually in terms of millions to billions of years. And then oxygen, well, you should immediately associate oxygen isotopes with paleoclimate studies, not really the geochronology of rocks. So remember, for granite, stick with long-lived radiometric dating methods like uranium lead and rubidium strontium. So that wraps up this ASBOG sample practice question session. I hope this video helped you reinforce key concepts, gain confidence in tackling exam-style questions. Maybe you just need an introduction to what the exam-style questions look like. And then, as we discussed at the beginning, retrieval practice is one of the best ways to strengthen your understanding and improve your exam performance. Don't waste your time just reading lots of random facts. By working through exam questions like these, you're not just memorizing, you're training yourself to think like a geologist and apply a knowledge in a test setting. Also, it's just fun. If you found this video helpful, here's what you can do next. Check out the full 300 question exam series I have on Udemy for deeper practice. There's a link in the top right corner and below. For 5 days after this video goes up, I'll include a coupon link to get the exams at a discount. So drop a comment below with any questions or topics you'd like covered in future videos. Thank you for watching and best of luck with your ASBOG exam preparation. Keep practicing and I'll see you in the next video.